Good day. We are looking at this sheet of notes about ionic equations, and we have some interesting terms. We have non-ionic, which is often called formula equations. We have full ionic, also called total ionic equations, and we have net ionic equations. Now, non-ionic or formula equations are ones you've seen before. In this section, though, I'm really sticky about doing things right. Your equation has to be balanced. Formulas have to be proper. And in this chapter, you are always writing out the states: aqueous, solid, gas, whatever. So we are going to sometimes start you where I give you the formula equation, or sometimes I'll give it to you in words, and you have to come up with a formula equation. But there's nothing new under the sun there. This is stuff you're used to. But going to the next stage, the full ionic or total ionic or complete ionic equations, now what we do is we look at these things. We have to have our chart handy, except we don't really need it in this case because we've given you all the states. For anything to dissociate, it has to be aqueous and ionic. This is aqueous and ionic. Barium chloride, aqueous ionic. Silver chloride, not aqueous and ionic. And barium nitrate is aqueous and ionic. So it means we got to split these 1, 2, and third compound, and the silver chloride will come down the same. It does tell us if we had anything that was liquid or gas, don't have to dissociate it. So we had 2 silver nitrates, so that means we get 2 Ag pluses and 2 NO3 minuses. Have to have the charges, have to have the states. The barium chloride, well, it splits into 1 barium 2 plus aqueous and 2 chlorides, each 1 minus aqueous. We love when we run into solids because 2 AgCl solid comes down as 2 AgCl solid. It may be ionic, but it's not aqueous, so we cannot split it up. And we know with a nitrate it has to split up, and it splits into barium 2 plus aqueous and 2 nitrates aqueous. That is the hardest step in this game, splitting things up. Now, net ionic equation says, hey, let's just worry about what changed in the reaction. If you look at the Ag plus, here it is by itself. Now it's in a compound. If you look at 2 nitrates here, oh, I have 2 nitrates there. So I can delicately cancel them out. Barium 2 plus aqueous here, barium 2 plus aqueous on the right. Can cancel those out. Here I have 2 chlorides, and oh, now it's not on its own. It's with the silver. So for this example, I am simply going to end up with silver ions plus chloride ions becoming silver chloride. One thing to remember, if possible, you will lower the coefficients down to the lowest whole number ratio. So we end up with 2 Ag pluses plus 2 Cl minuses becomes 2 AgCl solid, but a 2 to 2 to 2 deal becomes 1 to 1 to 1. Some reminders at the bottom. Species, a fancy way of saying different chemicals that do not change or take part in the reaction, are not shown in the net ionic equation. The equation has to be balanced in terms of atoms and charges. And we have to have the lowest whole number ratio of coefficients. And that's it. Sounds easy, but when you see some of these questions, they're not quite so easy. Practice.